In this video, we're going to solve absolute value equations. Now, the ones we're going to solve in this video are relatively simple. They're simple because these are linear absolute value equations, so all of the terms in the entire equation are linear. But even more than that, they're simple because all the problems we're going to work, we'll be able to start by simplifying the equation down to, like an absolute value expression on one side and a constant on the other side, or at worst, a single absolute value expression on one side of the equation with a single absolute value expression on the other side of the equation. However, instead of using the cookbook properties that the textbook gave us for solving just these types of simple equations, what we want to do is we want to analyze, as we solve these equations in this video, we want to analyze them from the more general perspective that we use to solve any kind of absolute value equation, no matter how complicated it is, no matter how many absolute values are all over the place in the equation, and no matter what kind of expression is inside, quadratic, rational, whatever, radical, whatever. Okay, and so, but in the next video, we'll solve some more advanced absolute value equations. But the general procedure is, so for any absolute value equation, what you're going to want to do is, you're going to want to go to every single absolute value in the entire equation and then draw a number line. So just note that we're only, with absolute value equations right now, we're only considering real numbers. The variables are only going to be representative of real numbers, because in this case, it's a little bit more difficult to think about what the absolute value of a complex number is. And it's not that we can't solve absolute value equations with x being a placeholder for a complex number as well, but we have some more analysis to do and to understand absolute values of complex numbers. And so we're not going to be, right now in algebra, we're not going to be thinking about x when it comes to an absolute value equation or inequality. X is just going to be a real number. Okay, so you're going to plot a line like this, a number line like this, and then you want to mark off all of the points on this number line here. You want to mark off all of the crossover points. For each absolute value expression, there's going to be certain x values where the expression changes from positive to negative. And it could be one, or it could be multiple. If it's just a linear expression like this, then you just need to solve for where x equals 0. And that's where it's going to cross over. But if you had like a higher order polynomial, then there could be multiple 0 points where the expression equals 0. You want to go to every single absolute value and mark off all of those points. And as I mentioned, if you've got other expressions like a rational expression or a radical expression, something like that, there might be crossover points that actually don't correspond to where that expression equals 0. So you're going to need to be able to analyze every expression for all of the crossover points, but don't worry about that too much. Once you get through with calculus, you'll be able to look at any expression, no matter what it is, and easily figure out every single point where it could change from positive to negative. So, okay, from there, then you go to every absolute value, find all the crossover points for each expression inside each absolute value, mark those all off. Then from there you're gonna have all of these are boundary points. And what you're going to need to be doing then from there is go to each region, and you're going to have to solve separate equations for each region. But how are you going to solve the equation? You're going to solve it because in each region, we're going to have there's going to be certain values of x we're considering. Well, we know from pre-algebra how to simplify absolute value expressions if we're given a certain range of x values, particularly when they correspond to, if you're saying an x value to where what's inside the absolute value is always positive or 0, or what's inside the absolute value is always negative, then we're able to simplify the absolute value. And that's the idea. In each of these separate regions, we'll be able to remove all the absolute values and solve an equation. And so what happens is, in each region, you're going to solve an equation and get a value. But that value is not necessarily an answer, because you have to make sure that value is within the range that you're solving for. If it is, then it's a solution. If it's not, then it's not a solution. And you're going to want to go through each region. You want to make sure you solve an equation for each region to account for all possible values of x. And then if any x value you solve for is within that range of values you're considering, then it's a solution. If it's not, it's not. And then you have all your solutions. So that's the general procedure for solving any kind of absolute value equation. So let's go ahead and do that here. for these relatively simple absolute value equations. So, okay, the first step is you simplify the absolute value equation as much as possible. So subtract 7 from both sides. Now divide both sides by 2. Okay, now we can't simplify any further. And so the next step is go through that whole the whole analysis process. So we have one absolute value with just a linear expression inside of it. So there's just one crossover point. This is relatively simple. So, okay, we can see that this is 0 when x is equal to 4/3. Okay, so that's the boundary point. So we need to, we can start by, let's consider when x is greater than, like we need to solve equations for the entire real number line. We have to account for all possible variables. So we're going to say when x is in this region, that's when x is greater than or equal to 4/3. And notice that I'm saying equal because we simplify an absolute value expression. We can just remove the absolute values. If we know that the x values we're considering will always result in an expression that's positive or 0, then we can just remove the absolute value. So that includes 0. So this is x is greater than or equal to 4/3. Okay, is equal to 1. So 3x, add 4 to both sides, is equal to 5. X is equal to 5/3. Okay. Now, but this isn't necessarily the solution. We have to make sure that is this in the range we're considering, because otherwise it's not valid, because this is all based on the way we simplified the absolute value. So is x greater than or equal to 5/3? Yes, it is. So this is a solution. Okay, and you might say, well, don't we need to check our solutions for extraneous solutions with absolute value equations? No, we only had to do that. We only have to do that based on what the textbook says, because we're not using the general method. Where extraneous solutions come from in the standard method that the textbook teaches you is that you might get a solution and it might be something like x is equal to 1. Well, that wouldn't be a solution we can see, but we wouldn't, without using the general method, we wouldn't know that. So when if we got x is equal to 1 here, we plug that back in. We'll plug it back in here. It's not going to end up being a solution unless maybe it's a solution. We find it's a solution in this other region over here, but in general, it wouldn't be a solution. Okay, so, or no, if we found it was a solution in this region. Okay, so like if somehow if we got x is equal to 1 here, we crossed it out, but then we analyzed when x is less than 4/3, and we somehow got x is equal to 1 here, and then in that case, okay, it ends up being a solution. But in general, most of the time, if you get a value and it's not within the interval you were analyzing, it's not going to be a solution. So okay, so if we're doing x is less than 4/3, not less than or equal to. It's only we put this negative out front if this is, for the x values we're analyzing, this is going to be negative. So minus 3x plus 4 is equal to 1. Subtract 4 from both sides. X is equal to 1. Is that less than 4/3? Yes, it is. So that's the two solutions. Okay, we start by just simplifying as much as possible. That's what we do that's how we start any absolute value equation. Subtract 1 from both sides. Minus 3 minus 1 is minus 4. Multiply both sides by -1. Okay. And okay, so now we've got the crossover point we can see is going to be c is equal to -7. Okay, so when c is greater than or equal to -7, what's inside of here is going to be positive or 0. So we just remove the absolute value. So what we're doing, c is greater than or equal to -7. Yeah, notice how we accounted for here. We accounted for all possible values of x. X is greater than or equal to 4/3. X is less than 4/3. It's important to make sure you do that. That you look back and you say, okay, I've analyzed every single possible value on the real number line, that potential inputs. Notice how we did that here, right? So here we're starting with c is greater than or equal to -7, and then next we just need to consider everything that's less than -7. So, okay, c plus 7 is 4. C is equal to 4 minus 7 is -3. Is that greater than or equal to -7? Yes, it is. That's a solution. Okay. Yeah, so it's good practice to always check your solutions. But I'm just trying to tell you that this is one of those cases where technically you don't have to. Technically. If you make any math errors, you don't have to. As opposed to like with radical equations, you have to, or rational equations, for example. At least radical equations where you take a even power to both sides. All right, so now what about when c is less than -7? So now we've accounted for all values after we do this. So we simplify that. Since we know this is going to be negative, we can just remove the absolute value, put a negative out front. So minus c minus 7 is equal to 4. Add 7 to both sides. Multiply both sides by -1. Is this less than -7? Yes. So that's a solution. Those are the two solutions, the only two solutions. Okay. Let's start by subtracting 8 from both sides. 2 minus 8 is -6. Okay, here we have a special case. The special case is that, so, all right, we can plug in any y value we want, any real number we want for y, and we could get anything in here. But when we take its absolute value, can that ever be equal to -6? Well, no, because it'll actually never be equal to anything that's less than 0. The lowest it can be is 0, so there's no solution here. No solution. We can obviously see that. It's very explicit. But in general, for more complicated absolute value equations, there could be no solution, but it won't be as obvious. In that case, just go ahead and solve it like normal. So we can go ahead and do that here as an example. So we've got the crossover point is, let's see, -4/11. That's when this is equal to 0. So, okay, we can do, if we're greater than or equal to -4/11, then this is going to be positive. Subtract 4 from both sides. Is this greater than or equal to -4/11? No. No. That's not a solution. So, okay, now let's do y is less than -4/11. Okay, so in that case, we're going to have, so -11y -4. Okay, -6 plus 4 is -2. So, okay, is this less than -4/11? No. No solution. You see, we accounted for all possible values of y. Greater than or equal to -4/11, less than -4/11, that accounts for everything. We didn't find a solution, so there's no solution. So you see, you can, if it's not explicit that there's no solution, or like even the other special cases would be like there's all real numbers are solutions, then you could, if it's not explicit, then just go through the process to solve it, and you'll figure that out. Okay, let's add 1/3 to both sides. So we've got 1/3, or 1/2 is times 3/3 is 3/6. 1/3 times 2/2 is 2/6, so 5/6. Okay, so now the crossover point, we've fully simplified. Now we need to do this analysis here. The crossover point is going to be what? So when does 4 minus 1/2 w equal 0? So minus 1/2 w is equal to -4. So w is equal to 4 divided by 1. -4 divided by -1/2 is 8. Okay, so 8 is the crossover point. Okay, so, all right. If w is less than or equal to 8, then it's going to be positive or 0. So w is less than or equal to 8. Then we just remove the absolute value. Okay, so let's see, subtracting 4 from both sides, you get 5/6 minus 24 over 6. 6 times 4 is 24. So minus 1/2 W is equal to minus 19/6. So W is equal to minus 19/6 times minus 2 over 1. So W is equal to positive 19/3, which is that less than or equal to 8? 6 times 3 is 18. Yes, that's a solution. Okay, well, now what about greater than 8? So W is greater than 8. That means this is going to be, what's inside the absolute value is going to be negative. So let's see, minus 4 plus 1/2 W is equal to 5/6. So 1/2 W is equal to 5/6 plus 24 over 6, which is 29 over 6. So W is equal to 29 over 6 times 2 over 1. W is equal to 29/3. Is that greater than 8? Yeah, 9 times 3 is 27. So, okay. That's the two solutions. Okay, so now here, this is a little more complicated. Now we have two absolute values. So, okay, let's get the boundary points. So -1 is going to be a boundary point, and -5/3. So let's do 0. So, okay, -1, -5/3. So here's the different regions. So there's 3 separate regions. Okay, now it does, there is a symmetry involved here in the sense that, so the region where they're both positive and the region where they're both negative is going to be the same equation, because the negatives cancel, right? If you put a negative out in front of this and a negative out in front of this, the negatives just cancel. So it's the same thing as they're both positive. However, you have to be careful because, so, like, all right, if we start by saying that we're greater than or equal to -1. So in that case, this is going to be positive or 0. This is going to be always positive. So we just remove the absolute values on each. Okay, subtract y from both sides. Subtract 5 from both sides. Okay, so is -2 greater than or equal to -1? Well, no, it's not. Okay, but, I mean, you could say it's not. That's fine, and cross this out. But you don't want to say, okay, well, I don't need to analyze this region because it's the same thing as what we did here. Well, no, because remember, yes, what you're going to do here, whenever, like, okay, whenever we say y is less than -5/3, y is less than -5/3. In that case, this is going to be negative and this is going to be negative. So you simplify it by doing this, right? Well, because of the symmetry here, you multiply both sides by -1, you get this exact same equation, which means we know that's going to be y is equal to -2. Is going to be the solution. Well, is that less than -5/3? Yes, it is. So this actually is a solution. You see? It wasn't a solution in this case, but it is in this case. So you want to be careful. We just didn't need to solve this equation twice is all, technically. It's because it's the same equation as it is over here. So, okay, so we've accounted for, now we just need to do y is greater than or equal to -5/3, and y is less than -1. That's this region here. And that's going to mean that we've got, so 3y plus 5 is going to be positive, and y plus 1 is going to be negative. But the symmetry, actually, you get the same equation either way, because we can multiply both sides by -1 and make this negative and this positive. But it's good practice to just do this correctly, because in general, it's just because the symmetry works out that way. But in general, you'd have to get it right. Put the negative in front of the right the right expression. So, okay, 3y plus 5 is equal to -y minus 1. add y to both sides, subtract 5 from both sides, okay, minus 3/2. And is that between minus 5/3 and minus 1? Let's see. So 3/2 is 1.5. 1.67. So yes, it is. So this is a solution. Okay, same process here. We've got, let's see, x is equal to 4 and x is equal to minus 1/2. Okay, we can start with, let's see, if x is greater than 4, this is always going to be negative. So we can start there. X is greater than 4. This is always negative, and this is always positive. So minus 4 plus x is equal to 2x plus 1. Okay, subtract x from both sides. Okay, subtract 1 from both sides. And there we go. Is this greater than 4? No. So that's not a solution. So we've accounted for this region. Now, what about when x is less than or equal to 4 or greater than minus 1/2? So in that case, this would be positive or 0, and this would be, we want to do actually this equal to as well, because this would be, if it's equal to minus 1/2, this is 0. If it's greater than minus 1/2, this is going to be positive. So both of these sides are going to be equal. So we've got 4 minus x is equal to 2x plus 1. Add x to both sides. Subtract both sides by 1. Subtract 1 from both sides. Okay, x is equal to 1. Is that in this region here? Yes. So that's a solution. So we've accounted for this region. Now, okay, but now we need to do, so x is less than minus 1/2. What's going to happen here is that both of them are negative, I believe. Is that right? No. This one is going to be positive, and this one's going to be negative. But the symmetry here just means that we're going to be solving this same equation, because if we write this out, this is going to be positive. So 4 minus x, and this one's going to be negative. In general, this would be different than the first equation, in general. But it's just not, because we just have these isolated absolute values on both sides. Like, so multiply this by minus 1, this entire equation. What do we get? Well, there you go. That we already solved this. We know this is going to be equal to minus 5. But look, that's a solution. So that is a solution. You see? Okay. So the crossover points here, we just have one crossover point. They both cross over at 0. Okay, so let's do w is greater than or equal to 0. Then we've got 1/4 w is equal to 4w. But remember, let's solve this like a polynomial equation. We want to be careful dividing both sides by a variable. We could just, you have to just remind yourself that you're doing that. So 1/4 w minus 4w. So 1/4 minus 16/4 is minus 15/4. So minus 15/4 w is equal to 0. Well, we can see that's w is equal to 0. Is that greater than or equal to 0? Yes, it is. So, okay, there's that region. Now, what about when w is less than 0? So, in that case, both of these would be negative, so we do this. You know, it's like, but that's going to be the same equation. And so as this, right, because of the symmetry. But w is equal to 0, it's not in that range. So one solution here. Okay, so we've got, let's see. We've got x is equal to 7. X is equal to negative 4. So, okay, let's do x is greater than or equal to 7, this would be positive or 0 inside here. And this would also be positive or 0. So x plus 4 is equal to x minus 7. Subtract x from both sides, you get 4 is equal to minus 7. There's no solution here. If x is greater than or equal to minus 7, there's no solution. Okay. Now, what about if x, that's this region. What about if x is less than 7 and, let's see, greater than or equal to minus 4? Because that would make this positive or 0 inside here. So in that case, we've got x plus 4 is minus x minus 7. So x plus 4 is minus x plus 7. Add x to both sides. Subtract 4 from both sides. Divide both sides by 2. Okay, is this between minus 4 and 7? Yes. That's a solution. Okay. Now, one more region to go. So let's see. X is less than minus 4. That's going to mean that these are both, the expressions are both going to be negative inside each of these. So, but that's going to be this same equation because the negatives are going to cancel out. In general, it wouldn't be the same equation. We'd have to solve it. But we're going to get this same equation. There's no solution here. So there's just one solution. X is equal to 3/2. Okay, so let's see. The crossover point for both of these is the same. It's going to be when P is equal to 1/2. Okay, so if P is greater than or equal to 1/2, then, yeah, this is kind of confusing. So if this would be negative or 0. So, yeah, because it's hard here because if P is greater than or equal to 1/2, this is positive or 0. That's fine. But then this is negative or 0, which we still could, if it's negative or 0, we still could just put a minus out front. But let's just do this. We can kind of analyze this any way we want. So let's go P is greater than 1/2. In that case, this is always going to be positive, and so we can simplify that. We'll just remove the absolute value. Even if it's not going to be 0, this is always going to be negative, so we do this. Okay, so 2p minus 1 is equal to negative 1 plus 2p. Subtract 2p from both sides. Minus 1 is equal to minus 1. So everything's a solution, however, only when p is greater than 1/2. So all of these are solutions. All of these values are solutions. Okay, now let's just do P is less than 1/2. Because again, I don't want to put a negative out front if it could be equal to 0, and even though I guess we could do that. But I just want to show you we don't have to. So when P is less than 1/2, this, or is that right? Yeah, this is going to be negative. This is let's see. No, this is going to be always going to be negative. And this is always going to be positive. Yeah, so actually we don't have to solve this again because there's never a case where they're both positive. Yeah, I mean, you see how we're just analyzing different regions. So if P is less than 1/2, this is, so 2 times 1/2 is 1, but anything less than that, you're going to get a smaller number or negative number, smaller number than 1 or negative number. So this is always going to be negative. Here, when P is less than 1/2, you're either going to get something smaller than 1 or a negative number, so it's going to add, so it's going to be 1 minus 2p. But that's going to be the same equation as this, because we can just multiply this by minus 1. So all these are solutions. So we've accounted for all of this. Just we have to think about, okay, what about when P is equal to 1/2? We'll just plug it in, right? P is equal to 1/2. What do you get? 1 minus 1, 1 minus 1, 0 is equal to 0. So there you go. This 0 is a solution, so everything, all real numbers.